The law of physics. Archimedes and Boyle's law has a great influence on diving. You will now see some experiments explaining the laws that are so important to diving. To understand Boyle's law, you need to understand the relationship between pressure and volume. This is explained through Boyle's law. Pressure of a gas in a closed container is inversely proportional to the volume of the container. First experiment on Boyle's law. Here we see a pressure container filled with water. The container is holding a pressure gauge and an in and output of pressure. The container contains water and the tube is filled with air. Diver computer, where you can follow the depth. Tube with air and a float inside. Picture inside the container. Adding pressure. Depth increases. The air inside the tube is compressed and the float goes up. Pressure decreasing. Depth decreases. The air pressure inside the tube decreases and the float goes down. Second experiment on Boyle's law. Diver computer and soft drink bottle. Adding pressure. Depth increases. The air inside the bottle is compressed and squeezes the bottle together. Pressure decreasing. Depth decreases. Air pressure decreases and the bottle goes to normal. Experiment seen from above. If the size of a closed container is decreased, the pressure inside the container increases. If the size of a container increases, the pressure of the gas decreases. Imagine a gas shown here as blue molecules inside a cylinder with a movable piston and a pressure gauge. If the piston is pushed down, the available space inside the cylinder is reduced, which compresses the gas. This means the same number of gas molecules have less space to move around in and hit the walls with more frequency. Conversely, if the piston is pulled up, the available space inside the cylinder increases. This means the gas molecules have more space to move around in, with less frequency. In this case, as the volume doubled, the pressure is reduced to half. Archimedes' law. Archimedes' principle states that force of upthrust exerted by a liquid on a body is equal to the weight of the liquid displaced by the body when it is immersed in liquid. Here we see a container with water, a scale, and a subject. The subject is hung on the scale and lowered into the container with water. The subject's weight equal to 1.37 kilograms above water. The subject is lowered into the water. The subject's weight equal to 0.54 kilograms underwater. The subject is lowered into water and the water raises and the subject's weight decreases. When we subtract the weight above water with the weight underwater, we discover the amount of water the subject displaces, in this case 0.83 kilograms. An object immersed in a fluid loses as much weight as the displaced fluid weighs. In this experiment, we need sand, an empty milk carton, and a container filled with water. 500 grams of sand. Volume of the milk carton is 1 liter. We make a mark on the container to show how much we accept the carton to displace in the water. Adding the 500 grams of sand into the empty milk carton. Now insert the milk carton with sand into the container with water. As accepted, the 500 grams of sand displace exactly a half liter of water, making the water reach to our center mark. This experiment also explains why a ship is floating, due to the amount of displaced water, which is greater than the ship's total weight.